Hello, geometry students. I appreciate you finding time to get your notes taken care of. Today we're going to be looking at the second half of the discussion on volumes of our three-dimensional solids, and today we'll be looking at the shapes that only have one base. So we're looking at volume of pyramids and cones. Please copy down that title as well as the objective, and of course the objective will be to learn to calculate the volumes of pyramids and cones. As always, anytime you need more time to copy something down, press pause and then hit play when you're ready to move on. Okay, so let's take a look. Just like last time, we are going to have pretty much a cookie cutter type formula that will apply to all of our pyramids and cones, and we will have to adjust that formula according to the shape of our base. Okay, so here we go. Just like with prisms, we have a generic formula to help us with the pyramids and the cones. However, we still need to make adjustments to the formula according to the shape we are working on. Now, our formula for today is going to look very familiar, at least part of it will, to the formula we used last time. As you can see in there, we still have the area of the base and the height being considered. Okay, but there is a coefficient involved. We are looking at exactly 1/3 of the area of the base times the height. So same as last time, big B is your area of your base, H is your height of your pyramid, and once again, keep in mind that H does not necessarily have anything to do with from top to bottom. Height is measured perpendicular to the base. Wherever it happens to be, height will be perpendicular from it. Okay, so let's take a look at a few here. Find the volume of the pentagonal pyramid shown below. Now, of course, pyramids, the only thing that really changes from one pyramid to the next is the shape and size of the base. So that's going to be pretty much our only real consideration. However, with some of the measurements we have going on inside of pyramids, it is more likely with pyramids that we may be missing a piece of information and have to solve for it. Okay, so finding the volume of a pyramid, we have a formula, 1/3 big B little h. And let's see if we can't figure out what our missing variables are. Okay, big B. In order to figure out the area of our base, we better be able to identify what type of a shape it is and then apply the correct formula for that shape. So obviously our base is a pentagon. We can see that in the picture. And even if we couldn't see it in the picture, the problem tells us a pentagonal pyramid, so it is a pentagon. So being a regular polygon, the formula for the area of it will be 1/2 times the apothem times the perimeter. Okay, so let's see if we have the information that is needed for that. Looking into the diagram, do we have the apothem for our regular base? Now remember, the apothem leaves the center point of the polygon and goes directly over to the side, forming a right angle. And in this case, yes, we do. We have the apothem. It is marked as 5 units. Okay, how about the perimeter of the base? Well, they did not give us the perimeter of the base, but we have enough information to find it. We know that the base is a regular polygon, which means all the sides are the same length, and we have one of the sides marked as 3 units long. So we can take that 3 and multiply by 5 sides going around our pentagon, and we have 15 for our perimeter. Okay, so no real tricks there. We were able to get the information straight out of the diagram, and we have 1/2 times 5 times 15, so we have a big B of 37.5. Now the other variable that we need to be able to discover is our height, okay, which of course again does not have anything to do with being up and down inside of the figure. It is a measurement for how far it is from the base over to the vertex. So let's look at the diagram again real quick. The height would be from that center point that's connected to the apothem straight up to the vertex, and we do not have that measurement marked in there. However, we can build a right triangle inside of that pyramid using the apothem and the slant height. Look back at the diagram real quick. The apothem was provided for us. The slant height was provided for us. If we drop down the height inside of that pentagonal pyramid, then we should have a right triangle between the apothem, the slant height, and the regular height. And we do not know the regular height. But we have two sides of a right triangle. We can very easily find the third side by running through the Pythagorean theorem. Hopefully you already know that h is going to be a 12. This is one of the more popular Pythagorean triples where all three sides are whole numbers. This is going to be a 5, 12, 13 triangle. We've seen it a bunch. Even if you haven't got that one memorized yet, you could go through the Pythagorean theorem and we will end up with a 12. Okay, now that you have your area of your base and your height, we ought to have as much information as we need to plug into the formula. Area of the base from the previous screen was 37.5, and the height we just discovered was 12. And we've got 37.5 in the numerator, 12 in the numerator, and 3 in the denominator. So 37.5 times 12 divided by 3 is 150. Again, this is a volume calculation. Volume has 3 dimensions, so all of your answers will be in cubic units. Okay, since they did not give us a unit, we just put U on there, but it could be whatever, inches, miles, pink flamingos, whatever they have in the diagram. That is the unit of measure. Okay, let's look at another one. Okay, find the volume of the triangular pyramid shown below. Volume of a pyramid is found by 1/3 times the area of the base times the height. All we have to do is figure out what's going on with the area of the base and with the height and plug them in. Okay, so let's look at our variables. Area of the base. Our base is going to be a triangle this time. It did tell us it was going to be a triangular pyramid, and of course we can see that in the diagram as well. All right, so we need a base and a height of our base. Okay, so let's take a look at this diagram real quick of this triangle that we have down there. Now we know for a fact that the side of our regular base is a 4. It's marked in the picture. Okay, but we need to know the height of that base as well. So when we drop in the height inside of that triangle that is the base, we get the triangle split into 2 pieces, where the base side of it is 2 and 2. Now we have 2 right triangles inside of this base. We can set up Pythagorean theorem, find out what's going on with the height of the base, the triangular base, by going through Pythagorean theorem. We end up with a height of 3.46. Now be absolutely careful on this. This is not h that goes in the volume formula. This is h of the base, the height of the base, not the height of the pyramid. Okay, so this is a measurement that was needed for the calculation of the triangular base. Okay, well, the base of the base is 4. We know that we have side lengths of 4 on our base, and we now know that the height is somewhere in the ballpark of 3.46. So plugging in those values into the area formula, here's what we have. And the result of that calculation is 6.92. Sorry about that. If you heard that on the recording, I had to stop and answer my phone for a moment. Anyway, there is your area of your base, 6.92. Now, continuing on with the formula for the volume of the pyramid, we need to discover the height of the pyramid. How far is it from the base over to the vertex? Let's look back at the diagram real quick. Okay, in this particular case, the height was marked for us. You can see that 9 inside of the pyramid coming straight down from the vertex over to the base. So that is our height. Okay, so we didn't have to work on that one. We have the 9. Now we can go to the volume formula. 1/3 times big B times the height. Okay, well, we discovered from above the area of the base was 6.92. and then the height is 9. Okay, well, running through these calculations, we've got 6.92 in the numerator times 9 also in the numerator, and then divide by 3 in the denominator, and that gives us an answer of about 20.76. Again, they did not give any units, okay, but whatever the units were, they would be in the third dimension, units cubed. Okay, the only real thing we need to have a look at is, of course, our pyramids might not have a polygon on their base at all, might be a circle, we might have a cone. Okay, it doesn't change anything except for the type of formula that gets used when we plug into the volume formula. Volume is still 1/3 times the area of the base times the height. Okay, so let's see if we can work through our calculations. Our big B, what is the area of the base? Well, obviously we have a circular base this time, so we're going to use the formula for the area of a circle, which is pi r squared. All we need to know in order to calculate the area is the length of the radius, and of course our radius would be half of that diameter. That is 25. Okay, so again, it's okay if you convert to a decimal point with these with pi in here. So 25 squared pi is in the ballpark of 1963.50. Again, please do not round off until you get to the end of the problem. So keep track of these decimal points in your calculator until you get finished. Going back to the volume formula, we need to know little h, the height of the cone. How far is it from the base over to the vertex? Let's take a look back at the diagram real quick. This time the height was provided for us, 90 straight up from the base up to the vertex. Okay, so we have that measurement, no need to solve for it. There it is. And then let's plug into our formula. 1/3 times the area of the base times the height. The area of the base from the previous screen is 1963.50. Our h is 90 that we just discovered, and of course we'll have to divide that by 3 because that's the way the formula is written. Okay, the result of that is we end up with something very, very close to 58,905 cubic units. Now, some of you have been getting a little upset or concerned about answers that you've gotten because you've ended up with very large answers. Well, if the problem starts off with very large values, you are liable to end up with very large answers because this is a third dimensional measurement. Okay, 3 different dimensions multiplying by each other in order to get this one calculation. And plus, keep in mind, big numbers do not necessarily mean gigantic volumes or gigantic surface areas or anything like that, because the units of measure that are in a problem might be very, very small, like a millimeter. Okay, so even if you end up with 58,905 cubic millimeters, yeah, sure, that's quite a few of them, but a cubic millimeter is a pretty tiny measurement, so having nearly 60,000 of them might not be really all that large. Anyway, that is the end of the discussions on volume. Okay, so I appreciate you getting your notes taken care of. I would be suspicious of the possibility of a quiz concerning volume, so you might want to begin preparing yourself for that.